if you haven't yet, guess what? It's time to subscribe. Wait, there it is. Look at that. That's right. 109, 123rd gets
Oreo packet.
Oreo packet.
Oreo packets.
And you can save the kid.
Oh, by the way, by
Right.
subscribing, you're saving a dog and starving kids all over the world.
Oh, yes.
One subscription, 1 calorie.
That's right. So we almost have a full meal right now.
No, we don't. We are far from a full meal.
It does not have all the nutritional categories. All right, here we go. Last lesson for the year, the last new information. Okay. This is the standard form of the equation of a parabola. We've seen parabolas before. Remember, we've seen them before where we have this, ax squared plus bx plus c is equal to 0. You guys remember that? That was like all first semester. Okay. So we're not approaching it from the quadratic side. Whoa. We're approaching it from some of the basics of how a parabola is actually formed. Okay, so there's only three main components here. The main idea is that the parabola is equal distance. What does he think that means? What do you think that means? Equal distance?
That if you cut it in half.
That's a bisection. That would be equal. But equal distance is like parallel lines. This distance is the same as that distance, the same as that distance, the same as that distance, right? Equal distance just means it's the same distance for both. Mm-hmm. So this is how a parabola is actually formed. Let's look at this together. If I have the three components, we have this line called the directrix. Directrix. I always like that word. We have the vertex, with just like the vertex of a parabola, we already know it's on the very what? The very bottom, which is called the. On the bottom, it's the minimum. What is it called at the top? The vertex at the top? Maximum. Okay, so watch this. What we know is the vertex is equal distance from the directrix and the focus. And that is the definition of where we find that. So you see those are both equal. And the value that breaks those apart is p. P is one of the most important parts of this. But how we form a parabola is actually based on the same distance. The vertex is the same distance between the focus and the directrix, right in the middle. But then the parabola actually follows a line. Let me just see. I'll just put it like this. I'll put it like that. Let's go up a little bit. So you see, if we were to build this like so, the same distance from, oh no, video fail. I can do it. Come on. Oh gosh.
It's okay, got it.
Got it.
Woo! Got it. Yes. So, yeah, the parabola is going to follow this same trend where it goes equal distance from the focus and the directrix. So the parabola has to follow this line. And then watch, I'll put another length here. Try to do better this time. Just like that. Right there, huh? So we see then that the parabola is going to be equal distance from the directrix and the focus. Equal distance, equal distance. So if I made this a little better, it would look something like that. Okay? You see the parabola? So would you guys imagine that over on this side, it's going to follow these same trends as well. There we have it. So all a parabola is, it's just equal distance from the focus, which you can't see anymore because it's covered, but from the focus and the directrix. The vertex is when it's just right above it. Okay? But then as we move out, these distances are going to be the same as we were to keep going all the way out. You see how that's kind of the symmetry of that? Just keep that idea. That's like the big idea. All right. So if we look at this, we have that focus, we have the vertex, we have the directrix. This p value is just showing that the vertex is halfway between the directrix and the focus, as are every single point. So I put this one dash here because these lines are the same. These lines are the same distance. Okay. So just keep that idea in there. The parabola opens up, down, left, or right, based on what that p-value is. Okay? So let's see. Right here is the focus. Here's the directrix. Where is the vertex going to be found? Where's the vertex going to be found? What do you think?
F.
That is the focus, F. So
Oh.
where do we find the vertex?
The D.
So focus, directrix, where the vertex is?
In between.
In between, exactly.
In between.
Vertex. You got it? Third time's
I
charm.
got there.
All right, redemption. Here we go. So now we know that the focus is here. Here's the directrix. Where did I find that vertex?
In between.
Right here?
No.
There?
No. Right there.
All right, how about that? Vertex. All right, here's the directrix. Here's the focus. Where is it going to be?
In
Right?
between.
There.
Vertex. Here's the focus directrix. Yeah. All right. So now we have the three points for those vertex. But now watch. Let's go ahead and put in our parabola. Is this one going to open up, down, left, or right? Opening. Opening. Because remember, that focus and the directrix, same distance all the way through. Right? How about this one? Up, down, left, or right? What do you think? Down. How about this one here? Up, down, left, or right?
Right.
Right. You're right. And this?
Left.
Left. You see how we have the 4 different ones? Okay. Now we can just categorize it. Once I show you this, and we actually do a practice problem, I think you'll see. Don't even worry. Okay. So, opens up or down. We have this equation. This is the main equation. This will be accessible for the quiz Friday. We just have x minus h. We see h again because that's the vertex. Is equal to 4p, which we can figure out because halfway between those two. Y minus k. So the center is the vertex is hk, just like the center of the circle is hk. If it opens up, then p is positive. If it opens down, p is negative. That's kind of like with a when we had our a value, right? Happy face, face positive, sad face, face negative. But in this case, we're talking about what that p value is. Okay, p can't be 0, that's just given. Same thing if it opens left or right, except for this entire expression switches places with the x minus h. See, that's the only difference, right? Ooh, 1 sec. I need to correct something right here. Yep. All right, guys. This here opens right to left. It's not squared. You see what I'm pointing at? Find that on your notes. Find that on your notes.
Mm-hmm.
Not squared.
Gone.
Okay. All right. I want to just show you how, opens to the right, it's positive. The positive numbers are to the right. Opens to the left, that's negative. Negative numbers to the left. Okay. So, looking at this, just wrapping it through here, wrapping it up. We're going to do a couple practice problems. These are really quick problems to jot down. But first I want to just look over at some of my drawings that I did. So if you had a satellite dish, 10 years ago on your roof, maybe you still have one, the shape of the satellite dish and that little sensor, the sensor that's outside a satellite dish, that is actually talking about the focus. All the light beams are focused by bouncing off that right back into the focus. So this would be my focus, and then the directrix for it would be over here. Right? This is my vertex. So it basically bounces off the parabola, which that's what all dishes are, and it goes right into the focus. That's where the sensor is, picks up the signal. That's how you see the image on TV. Let's get rid of this. That's not related. If you've been to the Exploratorium in San Francisco, there are these 2 seats that are about 100 feet apart. And people are walking through it, but there are these 2 seats with parabolic. They're huge. They stand like 10 feet tall. It's a huge parabolic. And your ear is right where the focus is. So you're talking to someone 100 feet away, but you can hear them like they're right here. It's really amazing. Because all the sound bounces off all the parabola edges and goes focused right to your ear. If you move forward a foot, you wouldn't hear it as loud. If you right there where you're seated, so it goes right into your ears, that's where your focus is. Okay. The last one is the 3D images you see on Facebook or wherever you're, I don't know where they are. You can turn the camera and look all the way 360. You've seen those as scroll. The way they capture that is they have some kind of parabolic mirror. The camera is looking straight down on it. So what it sees is, if you look down on a parabolic mirror, you see in all directions. That's how you're able to see in 360 degrees. So this is a clever idea that's applied a lot of different ways. Now, we want to be able to look at these example problems and not stumble. Let's look at them together. Find the equation when the focus is 0, 2. So watch. 0, 2. There is my focus. My focus at 0, 2. Directrix at y is equal to -2. So I go down for 2, -2 for y, and there is my directrix. All right, we did this pretty easy before. So where's my vertex? If the focus is at 0, 2, directrix at -2, where's my vertex?
In the middle.
Between them. Where's the point? What do you think? 0, 0. Focus is up here at 2 or 0, 2, so the vertex must be right in the middle between the focus and that directrix. So we'll say it's 0, 0. Okay. Let's go to, first, is this open, up, or down? We were pretty good at finding that over there. Up? Okay, so we know that, first off, opens up or down. So I'm going to copy this equation down. X minus h squared is equal to 4p times y minus k. All right. My vertex tells me what my h and the k are, so I'm going to put zeros in for here. It opens up. If it opens up, p is positive. And what is my p value right here? How far is it between there and there? It's going to be the same. How far is this? P equals 2. I know that p is positive because it's opening up. I can see it's going to open up like this. So p is equal to positive 2. Right? Let's plug in what we know. We know that h is 0. 4 times 2, y minus 0, or k. So watch what we're going to end up with. X squared is equal to 8 times y. Done. Not so bad, right? Not so bad? No. I don't know, that face. Let's look at example 2. So first step, I think after you see the steps, so really focus right here. We got 4 more minutes. Bring it all right here. First step is to graph what they give us. Find the equation when the focus is -2, -1, 2. -1 for x, 2 for y. That's my focus. Okay. Then I look to see where the directrix is. That's going to tell me if it faces up, down, left, or right. Directrix is x is equal to 7. Watch this. 1, 2, 3, 4, 5, 6, 7. Here's 7. And there is my directrix. All right, so I know that the vertex is going to be somewhere in this space because it's right in between the focus and the directrix. Here we're over at -1, -1, and 2. Okay. How far is it from -1 to get over to 7? -1 underwater, 1 foot. You go up to you're 7 feet above the water.
6.
Almost. From 0 to 7? 7.
Oh.
From 0 to -1?
8.
8. So if this whole thing is 8, where am I going to find the vertex that's halfway in between it? 4 of them, right? 4 away.
Don't beat yourself up.
Yeah, no worries.
Thank you, Jordan. Of course.
So we look at this,
Me too.
and 4 is going to be halfway in between. We know the vertex is halfway in between. So the vertex is right here at 3, 2. All I had to do was look to see that between the focus and the directrix, the vertex is halfway in between. So if it's halfway in between, I can find that whole distance, just cut it in half. So we know the vertex is here. We need to find our p-value. We already found was 4. Okay. So P is 4. Is this going to open? Here's the directrix. Going to open to the left or the right? Let's look at it. It's kind of like this. Directrix and focus. Directrix and focus. It's going to go over to the open left. So opening right or left, first I'm just going to copy this down. I know that it opens to the left, so P has to be negative. So that P is negative 4. And then watch, I'm just going to put everything in. Y minus K. K is 3. Squared is equal to 4 times negative 4. And then we have X minus, sorry, this is minus K, HK. Let's change this right here. You see it? Change this to a 2 because that's our K value. Now we're over here, it's X minus 3. That's my H value. K, H, P. That's all we have to input. All right, so now look at that. We're going to have Y minus 2 squared is equal to negative 16 times X minus 3 squared. Jeez. Where did that come from? Thanks, guys. 2 Starbursts for you.
Who gets 2 Starbursts? I said 2.
Hey, that's why there's 2.
Awesome.
Okay, so let's look over this one more time. First step was to plot the focus and the directrix. That's going to tell you if it opens up or down. The parabola never opens towards the directrix. We never have the parabola crossing the directrix. It goes in the opposite way of the directrix. So this was y is equal to negative 2, and here's my focus. So I know the vertex is right in between. So as you graph it, just count how many graph boxes you have there, and find right in the middle. Okay, so we find that vertex. We know it opens up or down, left or right. That tells me if we're going to use this equation or this. And also, if it opens up or down, we know the P is going to be positive or negative. P is positive or negative. So I knew this was 2. I know it opens up, so I know that our P value is positive 2. After you're done with that, your vertex values go in here, your P value goes in there, and you simplify it. Okay. I expect, because we had a little slower class, we're going to look over the homework tomorrow and bring your questions about that. No worries. All right, I need to give a final subscribe.
Can I take a picture?
Yeah.
Or is this just going to be on the YouTube?
It is on the YouTube too. All right, guys, I need you guys to help me remind people what subscriber gets some free Oreos.
On the 23rd.
All right, what should you definitely not do?
Unsubscribe.
And then subscribe. Okay, let's do subscribe on 3. 1, 2, 3.
Subscribe!
All right, if you didn't hear what they said, you need to subscribe because I have 109 right now, and I need 123. After the 123rd, there will be another prize, so don't worry if you didn't get it. Let's see what I have now. Maybe that's brought in more subscribers. All right, the big moment. 109. I guess I still need more. Okay. All right, guys, subscribe. Thanks. Last video of the year. Take care.